half-angle identities. We can use a cosine sum identity to derive our half-angle identities. You remember cosine of 2x is 1 minus 2 sine squared of x. Now, what I want to do now is just solve this for 2 sine squared of x is equal to 1 minus cosine of 2x. So sine of x is equal to plus or minus 1 minus cosine of 2x over 2. So you see I've gone from sine of x to cosine of 2x. Now let me let a equal to x because I'm trying to get to half angle. So this becomes a over sine of a over 2 is plus or minus the square root of 1 minus cosine of a over 2. Now, again, you have to pick the appropriate sign depending upon which quadrant a over 2 is in. Now let's start with cosine of 2x is 2 cosine squared x minus 1. And solve this for 2 cosine squared. Divide through by 2 and take the square root. Make the substitution. A is 2x. And I see that cosine of a over 2 is plus or minus the square root of 1 plus cosine of a over 2. And again, you're going to choose the appropriate sign.
There are 3 alternate forms for tan a over 2. We can start by saying tan a over 2 is sine a over 2 divided by cosine a over 2, substituting in the forms we have for sine a over 2 and cosine a over 2, and simplifying to get plus or minus the square root of 1 minus cos a divided by 1 plus cos a. When we, another thing we could do is say that it is equal to sine a over 2 over cosine a over 2, and then substitute in the 2 sine a over 2 cosine a over 2 divided by 2 cosine squared a over 2. Simplify and get sine of a over 1 plus cosine of a.
And we can also derive the identity that tan a is 1 minus cos a over sine a. All of the half angle identities that you do need to memorize. And be able to use. If I wanted to find the exact value of cosine of 15 using the half angle identity for cosine. Well, I know cosine of 15 is cosine of 1/2 times 30. Using the half angle identity, this is 30 over 2, so it becomes the square root of 1 plus cosine 30 over 2. And we want to choose the positive square root because cosine of 15 is positive. Now I know cosine of 30 is root 3 over 2. So now we need to get a common denominator and simplify this as the square root of 2 plus the square root of 3, all under that radical, over 2. Suppose I want to find the exact value of tan 22.5 using the identity tan a over 2 is equal to sine a divided by 1 plus cosine of a. All right, so I want a over 2 to equal 22.5, which tells me a is 45 in this case. So this is sine of 45 divided by 1 plus cosine of 45. Now I know sine of 45 is root 2 over 2, and so is cosine of 45. So doing a little bit of magic, multiplying by 2, trying to get rid of some fractions. I get that this is root 2 divided by 2 plus root 2. Now I don't want any radicals in the denominator, so I'm going to multiply by the conjugate of the denominator, which is 2 minus the square root of 2. So I get the exact value of tan 22.5 is the square root of 2 minus 1. Now suppose I want to find cosine of s over 2, sine of s over 2, and tangent of s over 2 if cosine of s is 2/3 And S is in quadrant 4. It's between 3 pi over 2 and 2 pi. Well, the angle, S over 2, is going to be in quadrant 2, since if I divide all of this by 2, I see that S over 2 is between 3 pi over 4 and pi. So sine of S is going to be positive, while cosine and tangent are going to be negative. It's really important you do that computation first off so that you remember.
Using sine of S over 2 is equal to the square root of 1 minus cosine of S over 2. Substituting in my numbers for cosine of S and simplifying algebraically, I get sine of S over 2 is the square root of 6 over 6. Cosine of S over 2 is minus the square root of 1 plus cosine S over 2. Substituting in my values and simplifying algebraically, I get cosine of S over 2 is the square root of 30 over 6. And tan S over 2, the easiest way to do this one is sine of S over 2 divided by cosine of S over 2. Substituting in my values, I get the square root of minus the square root of 5 over 5. So now let's simplify these expressions. Plus or minus the square root of 1 plus cosine 12x over 2. Now this looks a lot like one of our identities. As a matter of fact, it looks like an identity for cosine of a over 2. So if I put 12x is equal to a, I get this is plus or minus the square root of 1 plus 12x over 2 is cosine of 12x over 2, or cosine of 6x. And 1 minus cosine 5 alpha over sine of 5 alpha looks like tangent of 5 alpha over 2.
Now, how would I verify that sine x over 2 plus cosine x over 2 is equal to 1 plus sine of x? You want to start with more complicated side and just multiply it out. Remember that 2 right there. Now, you see you've got sine squared x over 2 and cosine x squared x over 2, and that's going to be 1. All right, plus sine x over 2 cos x over 2. So this becomes 1 plus sine of 2 x over 2 using the angle identity. And this becomes 1 plus sine of x.